Hello, everyone. I'm going to work through one example in section 1 of chapter 7. This section is integration reports in the chapter 7 of addition topics in integration. So this is another important technique of integration, integration by parts. And the first scheme we discussed before, strategy we discussed before, is called integration by substitution. We already discussed how to evaluate integrals by substitution. And this is another important tool that we can use to evaluate integrals. First, this integral parts formula comes from the rule in differentiation of product rule. So it involves, product two functions basically. In terms of integration, it exactly, has the correspondence in differentiation. So we are dealing with a product of two functions and we want to integrate it instead of differentiate it. So then, we can use this formula for integration by parts, but, we need to identify some function u and the v, functions u and the v. So this formula for integration by parts says, if we try to integrate u dv, okay, remember, so u and v are both functions. So dv here is the differential for the u, for the v, I'm sorry, which is defined as v prime, the derivative of v times dx. So u and v are both functions of x. Okay, so the integral of u dv is equal to uv minus the integral of v du. So in the second integral, we got function v and differential of u, which is the derivative of u times dx based on the definition. So what's the point? The point is, if you want to integrate, u dv and you don't know how to do it, then you might get it down by integrating by parts. If you, rewrite it as uv minus the integral of v du. Okay, so we have to do an example to see how this works and what the idea is. The important thing here and the key is to identify this problem as udv. So we have the problem to find the indefinite integral of the integral of x e to the x dx. So how do we compare this problem with the formula on the left-hand side? Okay, so first we have to consider the whole thing of x times e to the x dx as u dv. So then, for example, you can define u to be x and e to the x dx to be dv. Let's just do that. So let u equals x and dv, okay, equals e to the x dx, and it has to be exact. Okay, so we know dv is a differential, so on the right hand side it has to be a differential, so we got dx times e to the x, so that's also a differential. All right, so then we're going to find du and v. Okay, so how do you find the du? As before, we just take the derivative of u. So that's the derivative of x times dx. Okay, so prime of x, but prime of x is just 1. So we got 1 dx. So at the end, it's just dx. So that's du. And we call it the differential of u. It's just dx, and we need it because if we were to use the formula for integrating by parts, then on the right side hand we have du, so we need to figure out what it is. On the other hand, how do you find v from dv? Okay, so remember, if you think and dv is equal to the derivative of v, okay, times dx. So then what? Okay, so we got dv equals e to the x dx, but at the same time, dv is v prime times dx. So then what it says essentially is v prime is equal to e to the x, isn't it? So now we can, integrate e to the x to get a v, because integration and the differentiation, they are opposite operations. Okay, so if we know the derivative of a function is e to the x, then we just need to integrate the e to the x to find the original function v. Okay, that's also from the fundamental theorem of calculus, isn't it? Okay, so we just integrate e to the x. Okay, so that's easy to do, as we know. We're going to get e to the x, but we usually add an arbitrary constant c here because it's indefinite integral, but it turns out that it's not necessary, because at the end, when we do the original problem, we just have one arbitrary constant for the indefinite integral, so we don't have to include it here. We just add the constant, the arbitrary constant at the end in the final answer. Okay, so now we figured out du and v. So then we can plug in everything on the right hand side. So the original problem, the integral of x times e to the x can be rewritten as u dv, if we define u to be x and dv to be e to the x dx. And according to the formula for integrating by parts, that's equal to uv minus integral of v du. So now we just plug in everything and try to figure out the answer. So u is just x and v is e to the x. Okay, we did it here. And then minus the integral of v du. So let's see what it is. The integral of v du, so that's plug in v, so v is e to the x. And du it's just dx. Okay, we figured it out earlier. So everything becomes pretty straight now. So the first term x e to the x, we don't change it. And then we integrate e to the x. Don't we get e to the x itself? Okay. So, and then now we add the arbitrary constant at the end. Okay, so that will be the final answer. Okay, so this is a simple example by using integrating parts. One thing I didn't say to start is, the choice is not unique. We have chosen u to be x and the dv to be e to the x dx in this example, but you can also choose u to be e to the x. So you have two functions to choose for u, right? And then you let x dx be dv, and you can try to use the formula, to do the problem. But it turns out that will not work. You can double check by yourself. So the choice is important. That's actually the key for integration by parts. You have to choose the correct u and dv to start. All right. Otherwise, you will not get the problem down.